And it is the area unit. People use this kind of stuff all the time as they build and work on their houses and just all different areas. So, get it, area. All right, so a lot of this is going to be review, but some of this will be new as we work through this unit. And we're going to start with the area of parallelograms. Something you might already know is the formula for the area of a parallelogram. It is, of course, area equals the base times the height. Let's break that down a little bit so there's no confusion. The base of a parallelogram is the distance across one of the sides. The height, however, is not one of the sides on the other part. It is the distance running from one side to the opposite side, hitting at a right angle. That's your height. Be careful about that. Common mistake is to use one of the slanted sides as the height. You need to make sure you always have that right angle. But why does this work? Well, let me just clear this off for a bit. And let me draw that height in a different place. Suppose we were to draw the height right here and get this little triangle. Remember, this is a right angle. And we were just to bring that triangle over and attach it to this side right here. This is the best picture ever. We would get a nice rectangle. Let me highlight that for you so you can see it a little bit better. This rectangle right here. And the area of that rectangle would just be how long it is multiplied by how tall it is. So how long is this rectangle? Well, the distance across the rectangle is still the base of our parallelogram. It's that same side we had before, that base, and the height is still the height it was before. So it just kind of translates into the slanted parallelogram. Hopefully that was clear as mud. But let's summarize it on your formula master sheet. This is a sheet you'll be referring to as we work through this unit and the next. Now I've got all three of these because all of these are parallelograms. We break them down into rectangles and squares, but they all fit under that parallelogram umbrella. So they all have the same formula. The area is the base times the height. And I'm going to just write that down right now for all three of them. It's the base times the height. Now when it comes to a rectangle, because of the right angle in the corners, the base and the height of a rectangle are just sides of the rectangle. And when it comes to the square, the same is true. The base and the height are the same. Now, in a square, the sides of the square are the same. So a lot of times you'll see people identifying them as equal by putting S just to represent sides. And when we multiply the side by the side, we get just sides squared. So that's a simplified version of the base times height formula. Only works for a square. Now, parallelogram is maybe the trickiest one. The base of the parallelogram, if we put that at the bottom, and the height is going to go through the parallelogram, hitting that base at a right angle. A lot of times your parallelogram will be kind of unique in that the base is going to have to be drawn on the outside because the slant is such that you couldn't draw it on the inside. But if you extend that line for the base, you still can show where the right angle is. So there would be the base. Now remember, the base is only the side of the parallelogram, only this part right here, and then the height would be measured out here. In fact, I think I'm going to highlight all of these bases and heights for this diagram. Just to be nice and clear. All right, let's apply the formula. We're going to find the area and the perimeter of each parallelogram. So let me identify the base of this parallelogram and the height of this parallelogram to be really careful. All right, area first. The area is the base times the height. How long across the bottom is it? Well, we can pull that and steal it from the top. The base is going to be 32 inches across. And so let's plug that in. And then as far as the height goes, I don't know that height. And a lot of times that's going to happen in the problems we do. You're not going to know one of the dimensions you need. So we're going to figure that out using the right triangle that we have formed on this end. Let's steal the 20 inches and put it over here. And then we can do some Pythagorean theorem to figure out this height. But I'm noticing, and you should watch for these two, I'm noticing that 12 and 20, they both are divisible by 4. If you look at 12, that's 3 times by 4. 20 is 5 times by 4. So I'm thinking this is a 3, 4, 5 triple that's just been multiplied by 4. So I'm saying 16 is the height of my parallelogram. You can run that through the Pythagorean theorem if you didn't see that. But multiplying this together now, we've got 32 and 16 for a total of 512. Now this is a good time to pause for a second and let's take a look at units. Units are important when you're doing measurement. So these were inches. This wasn't just 32, but it was 32 inches. Let me squeeze that in there. And 16 was also inches. So when I take inches and multiply by inches, I'm going to make sure I write that as square inches. And all areas are going to have that squared type of unit. So I'm going to be watching for that in your work. Make sure you square those units. Okay, before we leave this problem, we do have to take care of the perimeter. Perimeter is pretty easy. We're just going to make sure to add all the sides up. Let's start on the bottom with the 32 and then work our way around. We get 20 next. Next across the top is 32, and then we finish off that last side with a 20. So let's add up all of those for a total of 104. And now this is just a linear measure. This is just still inches in perimeter. 104 inches. Okay, next, just another typical, here's a geometry problem. Find the area and perimeter of this one. We're going to have the same issue. We don't know the height. But in this one, notice we have a 45-degree angle. So this triangle is a 45, 45, 90 special triangle. Let's figure out the sides of it first. So we have a 9 yards here, and then we have a matching 9 yards here. And to go to the hypotenuse, remember, we're just going to multiply by radical 2. So let's call this 9 radical 2 yards on that side. Okay, ready to tackle area with our formula. Just take the base times the height. Across the bottom, we find our base. It's not 9 yards, it's the whole thing. You can steal it from the top up here. It's 17 yards. 17-yard base with a height of 9 yards. And remember, these are yards times yards. I won't do this every time, but I think it's good to do it a couple of times. Yards times yards gives me square yards. That's my unit. And then, of course, 17 times 9. We need to get that. We have 153 square yards of area. All right, perimeter. Now, perimeter, remember, we're adding all the sides. So across the bottom to start, 17, plus up that slanted side, we have 9 radical 2. Across the top, it's 17 again, and then 9 radical 2. All right, when you add radicals, you can only add them if they're the same kind of radical. It's like terms or like common denominators, same deal. So 9 radical 2 and another 9 radical 2. I'm looking at 18 radical 2s. And then separately, I'll add my 17s together. So that's a total of 34. I have 34 plus 18 radical 2s. I cannot add those together until I turn this one into a decimal. So this would be an exact answer if that's what I need. But if I want to go into decimal, let's just get what 18 times radical 2 is approximately. Do this on your calculator to make sure you know how to punch it in. I get it's about 25.5, about. So adding that now to the 34, we're getting a total perimeter of about 59.5. Now this was in yards, so let's put that unit on there. Now with this one, we have a chance to do a little creativity. We're going to have to split this area up because I don't know what this pentagon or hexagon or whatever it is, I don't know what the formula for that is, but I do know if I split it into pieces that I can get it. So maybe one way to do this would be just to chop it up into 2 rectangles. In this one, we would have a 9 by 5 rectangle. So 9 times 5 for an area of 45 here. And then this one is 6 by something. I don't know. We're going to have to figure that out. Remember, it was 5 on a side, so that can come over here as 5. And then if the whole thing is 10, that only leaves 5 for this last piece. So this bottom rectangle, that's a 5 by 6 rectangle. And that total area would be 30. Okay, so adding them together, I get 30 plus 45. And I don't know the units. We're just going to call these square units. A total of 75 square units. Now the cool thing about these problems is there's more than one way to do them. I'm going to do this a second way. Maybe you thought of this. There's even a third way I can think of to do it, but we won't take the time. Let's make our split right here instead, and let's see what happens there. Now I have a big rectangle. Be careful though, it's not 9 by 10. 9's the whole thing across. This is a 6 by 10, so this big rectangle is 6 times 10 or 60 square units. And our little rectangle is 5 by something, 5 times something. Again, I can pull my 6 up to the side here. So this is 6. This piece is 6. Out of 9 leaves only 3 for the last piece. And now I'm ready to go 3 times 5 or 5 times 3 for 15 in this area. Still though, the cool part is it's 60 plus 15, which is still a total of 75 square units. And I forgot to square that. Let's do that. And this over here is squared. I love that they get the same answer. If they don't, you should be freaking out. Something weird is happening. Okay, our final example, finding the height of this parallelogram. This is basically working backwards from our formula. They tell us the area, and we have to figure out one of the dimensions. So we have the area is 148. We're going to plug that in as our area spot. The base, from the picture we can see the base is 8. And then the height, we don't know. They've called it x. This is one of those examples where you have to kind of extend out this side. So that's x into the height spot. And you know what to do. You're just going to divide by 8 on both sides. Let the ninja work their magic. All right, so our final answer on this one is just 18.5 meters for our x value, our height.